In this video, I'll explain why you should avoid using SQL offset when implementing any kind of paging. I'll explain what offset does, why is it slow, and what is the alternative for better performance. This video is inspired by Use the Index Luke, and I'll have a link to his blog and slides to learn more. And if you're not subscribed to Use the Index Luke blog, what are you doing? This is an extremely mandatory blog to read for all database engineers. So check it out. So let's say you have a web application with an API that supports paging. Your user wants to request 10 news article in page 10. This is performed via a simple GET request as shown here. The API server receives the GET request and builds a SQL in order to send it to the database. Hopefully there should be a pool of already established TCP connection to your databases so you don't have to hit a cold start problem here. Page 10 translates to offset 100, assuming each page has 10 records, and now the database is ready to execute the query against this beautiful table. Offset by design means fetch and drop the first X number of rows. So in this case, the database will fetch the first 110 rows and physically drop the first 100 because guess what? You said it's offset, right? And then leaving the limit of 10 rows, which the user will be actually seeing, right? As the offset increase, the database is doing more work, which makes the operation extremely expensive. Another problem with the offset is you might accidentally read duplicate records. Consider this. The user has now requested page 11, which is now offset 110. And meanwhile, someone inserted a new record in your table. So now offsetting 110 rows will accidentally push your existing row that you have read before to your result set. Accidentally, now all of a sudden you just read a row that you have read before, which is row 11 in this case. Let us jump to the practical side and test this thing on Postgres, guys. Alright guys, I have a Postgres database and I have a table called news, not test. And there is an index on the ID. And I'm going to use the ID here as since of it as like a auto incrementing ID for my news articles here. And don't pay attention to these three fields. This is the title of the article essentially. What I want to do here is I'm going to use offset to start paging this, and I want to see how the database perform as a result. All right, so let's start with explain, analyze, select title from news, order by ID descending, because I want the fresh news first, and then I'm gonna start with offset 0, and then I'm gonna limit the result with 10. And then when I do that, instantly I get the results. Obviously we have two results. Let's explain what happens here. We're using index scan backwards, right? Because I did an order by ID descending, and indexes are already ordered by default, so the index was scanned backward from bottom up, I guess, and then there is this much rows in the index, but this is not really what we actually pulled is 10 rows. Why? Because offset 0 plus 10 rows, that is exactly 10. And applying a limit on top of that, giving you 10. So that's not so bad. It took 0.2 millisecond. But let's spy things a little bit. Let's start with offset 1000. And all of a sudden now, look at the rows here, guys. We have pulled from the index 1010 rows, 1000 plus 10. And that, on top of that, we applied a limit and then we only pulled 10. You're seeing the pattern, took 1 millisecond, right? That's not so bad. Let's make it 100,000. Ooh, you started to feel like 79 milliseconds. And guys, I run these queries many times, so there's a lot of page caches. So this might be slower first round, but you get the idea. So what happened here? We pulled 100,000 and 10 rows, and then only from those stinking 100,000 rows, we pulled 10. Can you imagine the work that the database is doing? Guys, think about this. This much rows, if this was SQL Server, SQL Server will immediately escalate the lock. It says, oh, we're touching this much rows. Bleh, who's going to die? But Postgres, thank God, it doesn't do lock escalation, right? So look at what's going on. We're working with 100,000 10 rows. We only actually need 10. And the unfortunate thing, the database doesn't know to do this because it's too late by then. All right. So you get the idea. Do 1,000,000. And you can start feeling it. It's going to be slower and slower, right? And if I restart the database, this is going to go so much slower, 620. And the first time I ran it took like 6 seconds, right? But you get the idea, right? Now, what can I do to fix this, guys? So what I'm going to do is going to do a little bit nice trick to actually accomplish that. I'm going to remove the explain analyze, and I'm going to remove the offset, and I'm going to simulate an offset by using the ID itself. And then since the ID field has a beautiful index, I'm going to use that as a page. Look at this. So there's not really rocket science what I'm doing here. I'm going to select the title and the ID, and let's say I'm going to pull the first 10 rows. And you return this to the user, right? And the user is responsible now to send you what was the last ID it saw. It saw or sees? It saw. It's past tense, yes. So now, what you do is basically execute the same query, but says, hey, don't bother returning anything after this ID. This is the last ID I saw, so I want older pages because you're going back, right? And it depends like how you go forward or back, right? You can play with this in your algorithm. But if I do this now, I got only these rows. And this is much, much faster. Let's take a look at the explain analyze. What are we doing? Explain analyze. And if I do that, look at the number of rows that the actual database worked with. Only 10. Why? Because if you do just limit 10, that's the best thing you can do. This is good. You didn't use offset with it. Using limit with 2 parameters like 10, 10 or offset, that kills the performance because now you have to jump and then read. Limit 10 tells the database, hey, I'm looking only on the first 10 rows that you can pull. There's another command called fetch first rows only, whatever, the first 10 rows. That's another thing you can use it, which is exactly the same as limit. All right. So if you do that, then you get back 10 rows. The index will be scanned backward, but it says, wait a second, we only need 10 plus we have used an index to actually filter that even better, right? We just essentially filter down the results, right? We're working with a little bit of a more niche result, which is awesome. And now, and then limit applied after the limit only took 10. Now, if I do this, if I imagine went back all the way to page, I don't know, 1,000, right? Page 1,000, which is very, very old. Guess what? Instant, right? We have worked, now the database worked with 89 rows instead of whatever, right? But still, the actual result set from the index came out as 10. Now we jump back to the heap, we pull the title field, and then we limit, and it becomes 10. So the amount of I/O is much, much less. The amount of work that the databases do is way less, and you saved a lot of CPU cycle, and the database will thank you. Hope you guys enjoyed this video. Guys, what are the other approaches that you personally do when paging? I'd love to see them in the comment section below so we all can learn and advance and become better software engineers. I'm going to see you in the next one. You guys stay awesome. Goodbye.